Now we want to look at the derivative of the graph of, or the derivative of the function y equals x squared plus 5x plus 6. Okay, derivative of that function is very easily calculated. Derivative of x squared is 2x, derivative of 5x is 5, so our derivative function is y prime equals 2x plus 5. Now, we have previously verified for a function of this nature that the derivative, or the axis of symmetry, is going to be negative b over 2a. b being 5 in this case, a being 1, that gives us an axis of symmetry at x equals negative 5 halves. Alternatively, we could factor this. We would find, and I think we have analyzed this function, we found that zeros occur at negative 2 and negative 3, very easily found by factoring, so that the axis of symmetry has got to be halfway between negative 2 and negative 3 at negative 5 halves. Okay, well, now let's look at the derivative of this function and see what the derivative could tell us about all that. Okay, the derivative of this function is 2x plus 5. The question is, when is the derivative equal to 0? Well, you could set this equal to 0, and you would get 2x plus 5 equals 0, a solution x equals negative 5 halves. Okay, so I'm verifying now that if x is negative 5 halves, y prime is 0, because if we plug negative 5 halves in here, we get this expression. 2 times negative 5 halves is negative 5, add 5, we get 0. Okay, so the derivative is 0 at the axis of symmetry, as we would expect for a parabola. Okay, because the derivative is 0 with a parabola flattens out. It flattens out at its vertex, and its vertex occurs on the axis of symmetry. The derivative is negative for x less than negative 5 halves. Okay, how do we know that? Well, we just solve the inequality, 2x plus 5 less than 0, and we get x less than negative 5 halves. What does that tell us about the graph of the function? It tells us the graph of the function is decreasing for x less than negative 5 halves. And then if we set the derivative greater than 0 and solve, we get x greater than negative 5 halves. Derivative is positive for x greater than negative 5 halves, so the graph is positive. The graph isn't positive, the graph is increasing for x greater than negative 5 halves. Let me correct that. Okay, now we've kind of been over all of that already. What we found out is the graph is level at x equals negative 5 halves, decreasing to the left of negative 5 halves, increasing to the right of negative 5 halves. We conclude that there's a minimum at negative 5 halves, that the y value of the function is minimized when x is negative 5 halves. So we've kind of depicted that here. Y prime is negative, so the function is decreasing. Then y prime is positive, so the function is increasing. Y prime is 0, so the function is level for at least an instant. And from all that, we conclude that y of x has a minimum at x equals negative 5 halves. And of course, we can find that minimum value, and we've done this already, just by plugging negative 5 halves in for x in the original function. We get the y value that's the minimum for this function. This function cannot go below negative 5 halves. Values cannot go under negative 5 halves. Okay. Now we're asked to calculate the second derivative of this function and see what that's telling us. Okay, so first derivative is 2x plus 5, so the second derivative is easily calculated. The derivative of 2x plus 5 with respect to x is just 2. So the second derivative is 2. It's always the same. It's always 2. Now what is the meaning of the second derivative? Well, the first derivative of y is the rate of change of y, which is associated with the slopes of the y versus x graph. Y double prime is the rate of change of y prime. Okay, it's the rate at which y prime is changing. What's y prime? Y prime is the rate of change of y, or the slope of the y graph. Okay, the y prime function gives us the slopes of the graph of y. So, since y double prime is the rate of change of y double prime is the rate of change of the slopes of the y versus x graph. Okay, so what's happening to the slopes of the y versus x graph if y double prime is 2? That means that the slopes of the graph of y versus x, the slopes of the, note the magical change in the wording here, the slopes of the y versus x graph are always increasing. Again, y double prime is 2, that's positive, always positive, and y double prime tells you the rate at which the slopes of the y versus x graph are changing. So since y double prime is positive, the slopes of the y versus x graph are always increasing. What does that tell us? Well, what does that look like? Well, it could look something very much like this. Your y versus x graph, as you know here, of course, is a parabola. The slopes, well, here's a slope, here's a slope, here's a slope, 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 okay? We have negative slopes on this side of the axis of symmetry and positive slopes on this side of the axis of symmetry. To the left of the axis of symmetry, the negative slopes are, well, they're negative, but they're increasing towards 0. We have negative numbers that would increase towards 0. The slopes would be like -5, -3, 0. Okay, then goes to maybe 3 here and 5 here. So negative numbers increasing towards 0, positive numbers increasing from 0. That's the trend of our slopes, and that's indicated by the fact that y double prime is 2. Okay, the fact that the slopes are, they might be negative, but they're increasing. So here we have increasing slopes because of the positive second derivative. So in summary, y prime equals 0 implies slope 0 implies level. That would be the case for this point down here. Indicate that point with an X, the point where the slope becomes level for an instant. Y prime greater than 0 implies increasing slopes in the neighborhood of this point. Increasing slopes would imply that the function is decreasing to the left and increasing to the right. In that case, you have a relative minimum. Should the second derivative be negative, that would imply decreasing slopes, okay? And that would imply this behavior, okay? The slope is positive, but approaching 0, and now the slope goes negative and continues increasing, at least for a while, at least in the neighborhood of your point.